Hello friends, so today we're gonna discuss this problem from the latest May lead coding challenge problem. Find all anagrams in a string. So you're given a string S and a non-empty string P. Find all the start indices of P's anagram in S. So P's anagram, or like this is a string of P's. So anagram of a string mean you can make a new string from this string such that you can rearrange the characters in this like word in any order. Then the new word which will be formed is an anagram of this string, like CAB or BAC is an anagram of this string. So you have to find out all the starting indices of all the anagrams in this string. So as you can see, there is CAB here. So the first it is start find at this index, and there is also ABC here, which is same as this. So the answer is 0 and 6. In this, as you can see, AB is present 0, BA is present this, and this is present. So as you can see how I am checking, I am actually making a window of the size of this string and checking. So can I go from this window to this window? Yeah, if I delete this character and increase this character, we can just directly go from this window of size 3 to the next size 3 window. It's very simple. So it's an O of n operation, and for each window what we will check that whether the number of characters in this string and this string becomes same. So how we can do it? We can make a frequency vector of this and check whether they are same or not. So let me tell you with this example. I've written down two uh, the same example. I'll tell you with I and j. So what we will do is we'll take this I and and match it with the first character, and first we will check with whether this length of this string and this string, so this is the anagram of which we want to find in this string, so its length should be less than or equal to this string. If its length is greater than, how we can an anagram of this string in this, so that can return false. Otherwise, if the string of this is less than or equal to this string, what we can do is we iterate over this length string because we have a window of this size and update our frequency matrix. So this is A, B, C and so on. So iterate over the length of this. So this is 1, 1, 1 and same as 1, 1, 1. Others are 0. Okay. Now after making the window size of this for this string, check whether both of these vectors are same. We can just do an O of 20, O of constant time just to iterate over every 6. It's just size 26 vector. So O of one time will take to check whether these are same or not. So if they are same, the first index is 0. Now to move to the next window, what we will do is we will minus this character and add this character. So our I is at this character only. So we will just add the frequency of this E and subtract the frequency of C, and check now whether this new string are same or not. No, so they are not same, so we will not push this. Now what we'll do is we will take this string, so delete the occurrence of A, subtract by 1 and add the occurrence of B by 1, so it becomes 2. As you can see now, the frequency in this is B is 2, E is 1, A, oh sorry, I've missed something. So it's actually in this string. So as you can see, we are just subtracting on the last character and adding the next character. Okay, so that's the main logic. Now how we can do this? We are at I is an index of this character, and the if we know the length of this string or the length of our window, then if we subtract I minus the length of our window, which is the size of this, then we can get to the index of our one which we want to remove. So we will add the character at index I and remove the character at this index, and if we found a match, we will insert this in our starting occurrence vector, so which we want to print out. Okay, let's write the code and it will be more clear to you. So it's a sliding window technique. So we will make three vector. One is f, size 26, initialize with 0. Next is frequency. These are both used to store the frequency of S and P. And the last one is answer, which will store the answer. Okay, if the dot size is greater than S dot size, then we just return empty vector, which is answer. Or else what we'll do is, we will first fill till the size of the window S of I minus A. This is to store the frequency of any character of the string S till the window size of P, and frequency of Pi. Okay, so if we check if f is equal to this frequency, it means which we have just filled. Yes, if this is true, answer dot pushback 0, because we have initialized the first value is 0. If this condition hold true, or else what we will do is our I will be from, because we have filled our f vector till this point, the first window value. Now we want to start from the next value, so which is p dot size, because we have filled at less than p dot size. So the next value will be p dot size. It will be less than s dot size. Now I want to fill the length of this string, which we want to compare, and what we will do is we will add the new character on which we are, and we will subtract I minus p dot size, which I have told you. And if at any point f becomes same as frequency, we'll just match the two vectors, answer dot pushback the starting index, which is I minus p dot size plus 1, and we just return answer. Okay. Let's check this. Given a right answer, let's submit this. Okay, s dot size frequency answer dot pushback. Okay, let me check again. Should be return here first thing. So as you can see, it's accepted now. I hope you understand the logic and how we are using it to find the next, adding the next alphabet and removing the last alphabet in the window. So if you like this explanation, please hit the like button and subscribe button to my channel. I'll see you in the next one. Keep coding. Bye.